In this last subsection, we shall look at hyperparameter tuning. Firstly, let's look at some common hyperparameters we could have when training deep learning models. We have the learning rate, which is a constant that defines our gradient descent steps. Then the choice of activation functions. There are different activation functions, like for example the sigmoid function, the ReLU function, and the tanh function. So depending on your problem, we have to be able to choose the best activation functions. Then the number of hidden layers. Basically here we are deciding on how deep we want our neural network to be. Then for the number of hidden neurons, for every hidden layer we want to decide how dense it's going to be. Number of epochs, for how many epochs are we going to train. We saw with the early stopping that the number of epochs can be reduced once we notice that the validation loss isn't dropping anymore, or that the validation accuracy isn't increasing. Then we have the amount of regularization. We saw regularization techniques like the dropout. We could decide to increase or to reduce the dropout rate. Then with the L2 and L1 regularizations, we modify the regularization parameter. Then the optimization parameters, we have the parameters for optimization techniques like momentum, ADAM, ADAGRAD, which have to be chosen. Then the embedded dimension, this is mostly with sequential data, and the choice of how large or how small this embedding dimension affects the accuracy of our model or how well our model performs. We have the byte size, which sometimes when too large can lead to overfitting, so we have to ensure that we choose the right byte size to avoid our model from performing poorly. And then there are a host of other hyperparameters which we can tune and which actually depend on the problem in which we're working on. But in general, what we do is we choose these hyperparameters initially, and then we evaluate the performance of our model based on the chosen hyperparameters. And then depending on this evaluation right here, we loop back to choose better hyperparameters so that we could reevaluate this performance and gain better results. And then we keep doing this till we get the best from our models, and hence the term hyperparameter tuning.